Class, Dr. Danju here again. Can you believe it? We are on our final homework assignment. I want to say thank you much for hanging with me. But today, what we're going to do is talk about regression analysis. All right. This is the final thing that we're going to actually cover when it comes to business statistics. Can we look at something and look at the independent variables and see how it affects the end result, the dependent variable? That is what we're going to be talking about today, regression analysis. So first, what I want to do is a quick review. Then we'll jump into our lecture, and then we'll knock out the homework assignment, hopefully at 100%. But as we're going through this class today, I want you to think about independent variables and how it affects the end result. Yeah, the dependent variable, and that is regression analysis. Regression analysis also uses a formula that we all should know about. Let me ask you guys this question. Do you know what the line formula is? So y'all like the line formula, isn't it y is equal to mx plus b? Yes, we're going to be using the line formula for regression analysis. It is going to help us to understand the strengths, the correlations between your independent variable and your dependent variable. It is also going to help us basically make predictions and forecast from the simple line formula. Let's go, let's go, let's go. All right, so let's get into a quick review. I'm going to share my screen, and as you know, my head is going to be on a swivel, so bear with me. All right, I'm going to make sure I get all of these here. All right, and I'm going to share my screen with you all. All right, so what we're going to be doing is we're going to be somewhere in between week 13, 14, and 15. All right, and then you'll see chapters 14 and 15. We've combined both of these chapters into one. Why? You guys already understand the concept of hypothesis testing. We can actually do two chapters in one. Yeah, yeah. All right. So let's get into a quick review. So I'm going to grab my PowerPoint. All right. And let's get into it. So let's review chapters 12. We talked about hypothesis test using the goodness of fit test. In the name itself, it tells you what the status quo is. This one, the status quo, what we expect to be true is it's a good fit. Your different categories, your different variables are a good fit. If you see rejected, it means that one or more of these variables are not a good fit. All right. So we have shown you guys how to use the goodness of fit test. All right, the next one, the test for independence. In the name itself, it tells you what the status quo is, what the null hypothesis, your H0, actually is. All right. If it says do not reject, it means that both competing variables, all right, are independent of each other. If you see rejected, though, in the results, it means that both competing variables are dependent or not independent on each other. Hopefully that makes sense to you. Last but not least, the test for multiple proportions. We're checking to see, are these proportions equal? The status quo is that, man, you can have three or more proportions, and you can actually put this into the hypothesis test for multiple proportions and see, are these proportions proportionately equal? All right. If it says do not reject, it means that your proportions are basically equal. Main. But if you see rejected, it means that your proportions are not equal. Yeah, yeah. Hypothesis test follows the same pattern. It doesn't matter which test you're using. All right. So this is why in chapters 12, we were able to do 3 hypothesis tests. All right. And then in chapters 13, we did ANOVA, analysis of variance. We're looking at different averages and seeing if there's a variation between these averages or not. We've shown you guys how to do it the manual way. All right. Based on the formulas up top, they'll give you this information and you can get your values. Once again, there's two ways to test to see if it's rejected or not rejected. You can use the test statistic or you can use your p-value. Please be reminded that the p-value is the easiest way to do it. If your p-value is less than zero point zero 0.05, less than or equal to zero point zero 0.05, then you know that this is going to say rejected. What that means is that your averages are not equal. Yeah, yeah. All right. So we've shown you guys how to do it with replication and without replication. So let's get into what we're going to be talking about today for our lesson. Today, we're talking about regression analysis. Regression analysis is going to be used in ANOVA, but it's going to go into more details. But with regression analysis, we can understand the strengths of our correlation. So we can have different independent variables and dependent variables and realize and recognize if they're correlated or not. Simple by putting it into a scatter diagram. It's pretty simple. All right. The line formula. Remember, the line formula, when you put things into a scatter diagram, is that center line. All right. We're going to talk a little bit more about that. All right. But we can determine the strength in a regression analysis, all right, by using a scatter diagram. We can actually look at and make forecasts. We can make predictions based on the current data that we have. And we can make forecasts and we can make predictions using the simple line formula. So as you guys know, I always want to talk about these topics from a Christian worldview perspective. All right. But so you guys can get a better understanding of this. What we're looking at is how does the independent variable affect or change the dependent variable? How does something that is not dependent on anything, all right, that is independent, how does that affect the end result? All right. So how does the amount of customers that show up to a store affect the amount of sales that you have? They're independent. Those customers that show up to your store, they're independent. How do they affect the amount of sales, the end result of that day? All right. We're going to be able to use regression analysis to tell us those types of answers. All right. But from a Christian worldview perspective, here is my question to you all. How does your independent choice affect your legacy? The independent variable is your choice or your choices. How does your choice or your choices affect the end result, the dependent variable of your legacy, your kids, your great grandkids, and the like? Yeah, yeah. All right. So, what I did was I went to Deuteronomy, and in Deuteronomy is where you guys are going to find like the 10 commandments. All right. And we're going to look at one of the commandments, and you guys are going to see how does someone's independent choice affect their legacy. All right. And we're coming from Deuteronomy 5:8 through 10. And it says this, you shall not make for yourself an image in the form of anything in heaven above, or on the earth beneath, or in the waters below. You shall not bow down to them or worship them. For I, the Lord your God, am a jealous God, punishing the children for the sins of the parents to the third and fourth generation of those who hate me, but showing love to 1,000 generations of those who love me and keep my commandments. So once again, here's the question. How does your individual choice or choices affect your legacy? So, according to the scripture verse, according to this commandment, if you choose to get like an image, let's say, for example, you think that lions are ferocious, and you decide to create an image of a lion, and then you decide to worship that lion, God says that is going to affect your generations for 3 to 4 generations. It's going to punish your children for 3 to 4 generations. Some of you guys may be saying, how can a loving God punish the children? All right. But can you see it from this perspective? Your decisions, your choices does affect and it does have consequences on your children and your children's children. All right. So just imagine you make a choice and your decisions affect your children and your children's children for 3 to 4 generations. If you decide to worship something that God has created on earth, something that God has created in the sky. Let's say you were to say the sun is the most powerful thing that you see in the sky. So I'm going to create a sun and I'm going to worship that sun. God is saying that that to him is like you're hating him. And the consequence of that is that your kids are going to be punished for 3 to 4 generations. Now, if you look at something in the ocean, let's say to you, a shark is like the biggest and baddest thing. All right. And you decide to make an image of a shark and worship that shark. God is saying, man, that is going to affect your kids for 3 to 4 generations. So here's my question to you. Why would you worship something that God has created as opposed to worship the creator of that thing? So, in essence, it makes no logical sense to worship something on earth, something above the earth, or something beneath the earth because God created all of those things. Why not worship Him? It says, but showing love to 1,000 generations of those who love me and keep my commandments. So if you were to put this on a balancing scale, which one would you do? Would you worship the things that God has created and affect your kids for 3 to 4 generations? Or would you worship the God that created everything and be blessed for 1,000 generations? You're not even at the point of 100-fold blessing. You at the point of 1,000-fold blessing, if that makes any sense. All right. Ultimately, we can see in the scripture verse that choices do matter. It does affect your legacy. All right. It can affect your legacy for 3 to 4 generations if you make bad choices. But if you make good choices, it can affect your legacy for 1,000 generations. Which one would you choose? Today, we're going to actually calculate and see how does independent variables affect the end result. All right. And we're going to be using regression analysis to do just that. All right. We're going to show you how to do a regression model, least squared methods, all of this stuff right here. Let's get into it. Let's get into it. One of the things that first we want to show you guys is the correlation. You guys are going to see R. All right. Correlation is a measure of linear association and not necessarily causation. All right. How are these two things correlated together? How does your independent variable and your dependent variable match up? It's not saying that it's causing it, but how well is it matched up? Here's a note to self. If your correlation, for the most part, is above zero point 0.7 or 70%, you will say, man, I got a good correlation. If it's below 70%, you now got to start looking. But there's many situations where correlations could be very low, but still very high. It all depends on the situation. But for the most part, all right, if it's above 70%, you will say you have a good correlation. Correlation can take on values between, all right, -1 and a +1. All right, so we got -1, strong correlation, weak correlation. All right, so when we look at it on a scatter diagram, all right, and I was actually talking about my R squared, but for my R, for your -1, it points downwards. When you put it on a scatter diagram, everything shifts downwards. That represents a negative correlation. A positive correlation is when everything points upwards. So you guys can actually see a better example of this. I will show it to you in a graphical display. If you were to put it into a scatter diagram, when it goes upwards, this will be considered a positive correlation. When it goes downwards, it will represent a negative correlation. All right, so how do you know if it's a strong correlation or a weak correlation? If your scatter diagram, if your dots in your scatter diagram is close to this central line right in the middle, you would say that it is a strong correlation. All right. Strong positive if it's going upwards, strong negative if it's going downwards. If your dots are all over the place, but not exactly on that center line, that trend line, then you would say that this is a weak correlation because these scatter diagrams, these dots are not tightly or close knit to that central line, that trend line that goes in the middle. All right. So if it goes up, once again, it's a weak positive correlation. If it goes down, it is a weak negative correlation. Here's something that you need to know about correlation as well. If your dots are all over the place, you can't tell if it's going up or down, it's just scattered all over the place, we will consider that to be no correlation at all. But if it's also on the trend line and it goes straight over, all right, it's flatlined, we will also consider this a strong no correlation, all right, because it's exactly on that trend line. All right. So what will we be using for regression analysis? We will be using the line formula. The line formula, as to remind you, it's y is equal to mx plus b. In business statistics, they kind of switch it around, but it means the same thing. Instead of y is equal to mx plus b, they're doing y is equal to b plus mx. If that makes any sense. All right, they flipped it around and they flipped it around for a reason. When you guys see the results, this shows up first. All right, B0 shows up first, then B1, and then your X value. The X represents your independent variable. The Y represents your end result, your dependent variable. All right. And I don't know if you remember math, all right, but the B0 represents your Y intercept. Where does this trend line hit the Y intercept? All right. So you can look at all these different trend lines. Where does it hit the Y axis? That is your B0. Your slope for every X, how many Ys do you go up to get to your trend line? Yeah, yeah. So for your slope, it is your X as it compares with your Y. And where is it for every X? Where is that Y axis point? Yeah, yeah. All right. So now that we have this, we're going to be using the simple line formula to make predictions and to make forecasts. All right. And we're going to use a scatter diagram to understand the strengths of our correlation, the R. All right. And once again, we're going to be using a sample for all of this. All right, so let's get into this so you guys can actually see how this works. When we're dealing with regression analysis, we're dealing with an independent variable and a dependent variable. Please be reminded that the dependent variable is your end result. All right, so for example, we got house prices and we got square footage. Which one would you think is the independent variable? Square footage or the house price? Which one ah, is something that won't change? All right. In this example, square footage is your independent variable. All right. Your square footage is going to be your square footage. All right. Let's say you got a house and your square footage is 2,200 square feet. That is what the square footage is. It's independent. That's not changing. That's the size of your house. All right. Unless you make it bigger or get extra land or whatever the case may be. But the square footage is the square footage, right? The house price is dependent on the square footage. So that is why that becomes the dependent variable. All right. So let's say, for example, we had in the last month these lists of house prices with these lists of square footages. Can we put these into a scatter diagram? So right here, they put them into a scatter diagram and they put a trend line right in between all of your dots. All right. And what you can see with your eye is that these dots are pretty close to this trend line. So you can actually look at this and say that this is going to be a good correlation, a good R value. Yeah, yeah. And as you can see right here, it's at 58%. But once again, once it's around 70, you will consider this a good correlation. Good enough, anyways. All right. It is not exactly on that trend line, but it's pretty close to that trend line. When we're dealing with regression analysis, we can only make predictions within the lowest value and the largest value. Some people like to make predictions outside of your data. That is not recommended. That is not justified. You can only make predictions. You can only make forecasts within the parameters of your data set. All right. So, for example, the lowest square footage that we have right here is 1100. All right. I'm just eyeballing this. The lowest is 1100. So we can only make predictions from a 1100 square foot home all the way up to the highest looks like 2450. All right. 2,450. We can make a prediction of any house price once we have a square footage and we're using the y is equal to mx plus b formula. The way it works is we can actually put it into a regression analysis and get our results. This first answer on the coefficient is your B0. Yeah, yeah. Where that thing hits the y-intercept. Where does this trend line hit this y-intercept? At this number right here. That is your B0. Hopefully that makes sense. Your B1, where it is your slope, is this second number right here. All right, that is your slope. Once you have these two numbers, you can make predictions, you can make forecasts. All you have to do is put in any square footage between 1100 and 2450, and you will be able to make a prediction of how much that house price is based on the data that you have gathered. All right, hopefully that makes sense to you. We're going to show you how to put it into a regression analysis and get all of that stuff rolling. All right, they're going to talk about the sum of squares, all right, for your treatment, the sum of squares for your um, regression, sum of squares for your error, all right? We're going to put them into a template just like we've been doing. Right, and we're going to show you how to do this. All right, so we can see that this right here is going downwards. All right, so you would expect this to be a negative correlation. Yeah, yeah. All right, and it's not -1. If it was -1, it would be exactly on that line. If it was +1, it would have went upwards, and it would be exactly on that line for 1. All right. So it's not a positive. This one is a negative correlation. All right, good, good, good. We're going to also provide you data, and you're going to be able to calculate these numbers right here just by putting it into our template. All right, good, good, good. On the exam, you're going to get some data. You're going to be able to put it into a scatter diagram. All right, get your trend line, and then make your predictions. All right. Here is your B0. Here is your B1. And when you get these two, you can then make predictions. All right. So if your X is 5, what is your predictions? And we want to make sure that this is set to 1 decimal place once we get there. All right. So we're going to keep this thing rolling. Some examples. All right, great, great, great. And these are all from chapters 14. Chapters 15 talks about multiple regression. Multiple regression is the same as just a regular regression. Only difference is that you have multiple independent variables. All right. So here's our B0. Here's our first independent variable, price. Here's our second independent variable, advertising. How does price and advertising affect the final results of sales? Yeah. So I can show you guys this. All right, we got that, we got that. So let's say we were to have a pie that we're selling. All right. How does the price, changing the price, and how does advertising change the final sale price of this good, delicious pie? All right. So we will get the information. This is your prices that you have set in the past or the pie sales. All right, this is the end results. This is the price that you have set. This is how much you paid for advertising. And then you can put it into a regression analysis. You can actually see how this price affect your final sales. All right. It's going down. It's a negative correlation. Every time you raise the price, you get less pie sales. So just looking at this, you're like, look, man, we need not to raise the price because it's not helping us. We get less if we raise the price. You see, the price goes up, it's a negative correlation. All right. Here, you're spending more on advertising. It's a positive correlation. All right. So the more you spend on advertising is the more your pie sales go up. So which one would you do? Would you raise the price or would you pay more for advertising? Just looking at this scatter diagram, you can see, looky, pay more for advertising. All right, good. So we got all of this stuff, all these formulas, but ultimately we're going to put it into the multiple regression equation within Excel, within your data analysis toolkit, and you will get these results. And from these results, you can tell, is it a good correlation or not? All right. So once again, if this number is less than 0.05, then you will say reject. All right. Your p-value for your f-test is this one right here. Even though it says significant of f, this is your overall p-value. All right. And as we get into the homework, we're going to show you how to get these individual p-values to see if this one actually does affect the end result or not. Does advertising affect your end result or not? All right. And from this, just looking at this, eyeballing it, both of them do affect your final sales price. All right. So with that said, can you please open up your Excel? Can you please open up your Cengage for chapters 14 and 15? What we're going to do is we're actually going to now take this information that I've put on a high level perspective and put it into practice. All right. So if I were you, please go into your classroom. All right. And for those of you who are not in my classroom, if you were in my classroom, you can click on class resources and get to the Trello board. In the link below is where you'll find the link to the Trello board. Go to the Trello board. Here's mine. All right. And can you please download chapters 12 through 15's Excel template? Scroll down and grab chapters 14 and 15's Excel template. Click it. Wait for it. Download it. All right. Once you have it downloaded, please enable it and save it. So file, save as, please put it somewhere on your desktop. And hopefully by now you have a folder for BUS352. So let me scroll down to my desktop. Here's my BUS352 folder. I'm going to save this Excel's template in here because once again, we will have 5 questions on this Excel template that will show up on the exam. So I'm going to save it. All right. Once you have this saved, please go back into Cengage, go back into Halo, and grab chapters 14 and 15, find it wherever it is on your calendar, click it, open the assignment, and let it load. All right, as that is loading, you know how I do. I like to do a dual screen. Please do a dual screen on your end. All right, I'll accept that for right now. All right, I'll slide this over to the right. Good. And I'll grab my Excel. Good. Start that. Excellent. Can we please start off with 14.01? All right. So click through until you find 14.01. All right. So here's 14.01. All right. We're going to actually plug in our data right up in here. All right. You see that 1, 2, 3, 4, all of this stuff. Plug it in, and then we'll do a regression analysis. All right. So before I actually get that started, um, let me check to see what are all the questions that will be coming on this exam. All right. So 14.01 is one question that will be on the exam. So we got to make sure that this is right. And please be reminded that this needs to be set to one decimal place. So when we get to this answer, we're going to move it over to one decimal place. 14.01, 14.18, and 14.035. All right, good. All right. So if you would please, in 14.01, please plug in the numbers like you see them. Good. Plug in your Y information. All right. And I'm going to maximize this so you guys can see this. Here is my scatter diagram. Do you see how these are pretty close together if I were to do a trend line in between them? Some of you guys are like, how do you actually do a trend line? You need to do a trend line for all of this. So if you click on the data itself, click in here. For my Windows users, you're going to see this plus sign that shows up right here. You can click it and you can make sure that you click on the one that says trend line. All right. And that will put that trend line right in between those dots. Do you see it? Hopefully you can see it on your end. All right. For my Mac users, click in here as well. And I want you to click on chart design. Click on add chart these elements, add chart elements, click on trend line, and please make sure that you're clicking on the one that says linear. All right, so for my Mac users, please use that process. All right, now you have your trend line. So you can actually go back into Cengage. Oh, let me find it. Go back into Cengage, all right? And which one is it? Is it going downwards? Is it curvilinear, or is it basically going upwards? This one should be on my end. It is set to 3. All right. So for you on the exam, you're going to have to go through, look at your data, and select the correct one. Yeah, yeah. So there appears to be, all right, it appears to be because it's going upwards, positive. Yeah, yeah. So just check your work just to make sure. Good. It is positive. Now, which one is it with the trend line included? Come on. Don't get this wrong. Don't get this wrong. Once again, for mine, it should be 3. All right. I'm going to check my work, make sure I'm good. Make sure that you are good on your end as well. So yes, indeed. Now, when you see these two right here, it is saying, what is your B0 and what is your B1? So what we're going to do is a regression analysis of this data right here. All right. So what I'm going to do is I'm going to click on this. And what we're going to do is click on data, data analysis. And don't forget, if you do not have your data analysis right to the right, when you click on your data tab, all you need to do for my Windows users up here, just type in add-ins. Yeah, yeah. Just type in add-ins and make sure that your analysis tool pack is selected. Just that one. All right. So I'm going to click on data, data analysis. And what we're going to do is look for regression. Yeah. Do you see it? Do you see it? Click on regression and then press OK. All right. This is what I like to always remind you guys because a lot of students mess this up. Your Y's are your dependent variable. Your X's are your independent variables. All right. Now, think about this from a relationship type of perspective. Do you want to mix your exes and your wives together? Mm-mm. You want to keep them separate, keep them in their own category, keep them categorically separated, if that makes sense. All right. So my Ys must go with my Ys, and my X's must go with my X's. So when I see Y, I think of wives. When I see X's, I think of exes, ex-girlfriends, whatever. All right. So I'm going to click on my Ys. And I'm going to make sure I'm going to start from my wives and select them. Yeah, yeah. hmm And categorically, I'm going to take all of my X's and put them into the X's inputs. Yeah, yeah. Make sure that you select in labels, confidence level, and we're going to throw this output right at this orange box right here. All right. And that is it. For all this rest of stuff, you guys can mess around with this on your own, but this is all that we'll need for our class. So once you press OK, Splaka, you will have your B0, your B1. Here is your test statistic. So if I were you guys, you can type in up here, test statistic. All right. I'm going to zoom in because I know you guys, it's going to be hard for you to see it. And here is your overall p-value. All right. So if you're looking for the overall p-value, it's your significance of F. If you're looking for your test statistic, it is your F value. Now, once again, if this number is less than 0.05, is 0.01 less than 0.05? Yeah. All right. So what this means is that your independent variable does affect your dependent variable overall. All right. This is what this is saying. All right. So with that said, I'm going to slide this back over. All right. That B0, let me zoom out. This B0, let me go down just a little bit right here. This B0 will automatically show up right here as your B0. This B1, if you did it right, will show up right here. So those are the two numbers that they're asking for, zero point 0.6 and 2.4. Check your work. Yes, indeed. All right. And then on the exam, they're going to ask you, all right, using the estimated regression equation to predict the value of y when x is equal to 3, all right, can you find the y? All right. If your x is 3, so right here, please enter 3. All right. So let me see. I will put change on exam. All right. So you remember whatever value they provide you right here, please change it on the exam. Now, this number needs to be one decimal place. So please move it over to one decimal place. Move it over. Please make sure that this is set to one decimal place right here. Yeah, yeah. All right. And then you should be able to get your answer. Check your work. Scroll down. Yes, indeed. So once again, we can use regression analysis to determine, is this one independent variable? How does it affect the end result? So to go back to my data, so you guys can see this. How does the X's in my example affect the Y's? All right. Based on this, the result is that the p-value is less than the alpha value. So therefore, the X's does affect the Y's. Hopefully that made sense to you. All right. If you would, please, let's go to 14.18. 14.18. All right. So I got 14.18 there. Click through until you find 14.18. Bam. All right. I believe this is also an exam question. So please let's make sure that we get this one right. All right. So we got price. and we got score. All right. Which one would you consider the independent variable between price and score? All right. So they actually give you the answers right here. Price is your independent variable. Score is the end result, which is your dependent variable. All right. So please plug in your information as you see them. All right. All right, so once you've plugged in your information, we'll do the same thing like we did before. For our scatter diagram, if you click in here, just make sure that everything is selected. All right, here's my data that I've got. Please put a trend line in there. And once again, for your trend line for my Windows users, you can click on this plus sign and click on the trend line open dialog box right here. All right, you can click it. For my Mac users, please go to chart design, add chart element, go down to trend line and click on linear. All right. So here is my trend line. So I would say these dots are pretty good, somewhat close to being very good correlated together. All right. How does price affect scores? It's a pretty positive correlation, strong positive correlation. All right. But let's go to your data analysis. And once again, we're going to do regression. Press OK. All right. Once again, please delete all of these. And we're going to put the X's with the X's and the Y's with the Y's. All right. So I'm going to click on right here. Here are my Y's. Gimme, gimme. Here are my X's. Gimme, gimme. I got my labels. I got confidence level. And I'm going to drop this joker right at I13. Hey, all right, right here. All right. It may show up like this, but ultimately you're dropping it right here. All right. So once you have that, press OK. Sparker. Here is your B0. Here is your B1. Yeah, yeah. All right. And for this one, here's my B0. Yeah, yeah. Here's my B1. All right. Hopefully that made sense to you. So what I'm going to do is slide this back over. All right. But they don't want B0. They want SST, SSR, and SSE. All right. SST is first. So if I were you, I would put first because on the exam, you're rushing, you're not thinking about it. You're going to put in probably SSR first. All right. So if I were you, I would take this, redify it, boldify this joker. I would even bigify it. So I would be reminded that this is first. Yeah, yeah. And what we're going to do is set all of these, all right, to 3 decimal places. Please make sure that you're setting all of them to 3 decimal places. All right. Some of you guys, when you try to set it to 3 decimal places, you're going to see this pound symbol. What that means is that there's not enough room to display all the numbers. So you're going to have to drag it over. So go between E and F and drag it over. Yeah, yeah. So you can have your 3 decimal places in there. All right. So that's my first number. I ain't got time to type all that stuff out. Just going to copy and paste, check my work. Yes, indeed. All right. Then the second one is your SSR. So I'm just going to put second. All right. Once again, I'm going to ratify it, bigify it, make it somewhat smaller. You know what? I'll make it even bigger. All right. So I know that's my second one. All right. I'm just going to copy this. SSR. Good. Check my work. Yes, sir. And then my SSE is this last one right here. I'm going to copy this. I'm going to paste this right here. Check my work. Yes, indeed. So just to keep everything formatted basically the same, this is my third. All right. I'm going to redify, bigify, and I'm just going to leave it smaller. So once again, This is the last one that I'm dealing with. All right, make it work however you choose to make it work. Make it do what it do for you. All right, so once you have that, then it's going to come in here and say, what is your R squared value? Do you see your R squared? Copy that, paste that, check your work. All right, good. And then it says, okay, so I was talking about my R squared. Hint, if your R squared is greater than zero point 0.7, R squared, all right? The estimated regression equation provides a good fit. All right. So right here, the least squared line, isn't this better than zero point 0.7? All right. It provided a good fit for a larger. All right. So I'm just going to check my work. Perfect. So what I want you guys to do in your Excel as well, please type in there provided and then a large. So that way there's no guesswork on this exam. Yellowify that. Make sure that you're documenting everything. Everything is set up correctly. This provided a large. And then last but not least, your RXY. This is this last yellow box right here. Copy that. We're going to paste that. Check our work. Yes, indeed. All right. So some of you guys, got eyes like mine. All right. You need your second and your third glasses. So what I'm going to do is I'm going to come into my R squared right here. I'm going to redify that, boldify that, bigify that. All right. So when I show up, uh, not that one. Give me a second. Um, okay. This guy right here. This is the R squared I want to redify and bigify. All right. So on the exam, I'm not searching for where's R squared. All right. And I could have made that mistake of seeing it down here. Now, here's my R squared. All right. And here is my RXY value. So do the same thing. Ratify it, boldify it, bigify it. Help you. So that way you can actually see this. All right. So we should have 14.01 right. We should have 14.18 correct. Right. Let's go to 14.21. Click through until you find it. Hey, good work, good work. All right. Production volume and the total. The total is the end result, the dependent variable. So all you need to do, maybe we can copy and paste. Let's see, copy. And we're going to paste it. Hey, let's go. Copy paste it over there. You should be able to see what your correlation looks like. Yep. All right. You can click it, put a trend line in there real fast. Good. All right. And then we're going to do a regression analysis really fast on this as well. All right. Once again, clear out all of this so you have no confusion. All right. Once again, put the wives with the wives. And put the X's with the X's. Include the label as well, please. All right. And we're going to drop this right here. Yeah. So once you have everything set up like mine is, press OK. All right, here's your B0. Here's your B1. Here is your test statistic. Here is your overall p-value. All right. So once again, is this number less than 0.05? Yes. So I would say that my production volume does affect my my total cost. Yeah. All right. Let's go into this. Let's see what all they want. All right. B1. Please be aware, Cengage tries to be a little tricky. This one, they're asking for the B1 first instead of the B0 first, right? So just be, savvy. Flip it around. Here's your B0. Oh, look, I'm already messing that up. Here's my B1. All right, and here's my B0. All right, so keep your head on a swivel. Make sure that you're plugging this in right, incorrectly. All right, and get this right. But when it comes to this is B0 first, and then this is B1. So please make sure that you get this right. hmm All right, good, good, good. What is the value? What is the variable cost per unit? Every time you hear per something, that is your slope. For every X, how many Y's? Per. All right. This is your slope value. So plug that in, check your work. Yes, indeed. All right. Now, what is your R squared value? You see down here, R squared, plug it in. A 0.9. All right, check your work, make sure you're good. Outstanding. All right, this took me a while to figure out, but for right here, what they want is what is the percentage? Change this to a percentage. Hopefully, you can see that 0.95 is 95.9%. Yeah, yeah. Go work, go work, go work. All right, last but not least, if you have a prediction of 500, what is your predicted Y value? And they want it to the nearest whole number. So you can literally just put in whatever number they provide you. It could be 600, it could be 500, it could be 200, whatever number, put it into the X and just then type in this number. I'm just going to copy and paste. Check my work. Good work. All right. Let's move on, please, to multiple choice 14.035. Good, good, good. I'm gonna click through until I find it. All right, 0.35. All right. So if the coefficient of determination is a positive value, then the regression equation could be positive or negative. All right, this is a little trick question right here. The coefficient of determination is r squared, all right? And if you know anything about math, r squared or anything squared cannot be negative. Like the actual answers cannot be negative. But right here, they're not talking about the coefficient of determination, even though they put it into the question. What they're saying is the regression equation. Just think of, forget the coefficient of determination. Just think of the regression equation could have a positive or a negative slope. Yeah, yeah. All right, that will be your answer. Please make sure that you ratify it. I'm going to select it. It could have either a positive or negative slope. All right, perfect. Now let's go into chapters 15, if you would, please. We're going to go into 15.13, and this is when we're dealing with multiple regression. All right, multiple independent variables. All right, so it says the following estimated regression equation is based on 30 observations. So put in 30. All right. You guys can put in this entire formula into here. All right. But you don't have to. We're just going to leave it blank. But for right here, your p-value, how many x's, how many independent variables do you have? I'm going to count for mine. One, two, three. Do you see x4? So in my case, I have four independent variables. How many does yours have? Put it in there, please. My SST, all right, SST and SSR, the first number is your SST. Your second number is your SSR. All right, this is the sum of squares for your treatment. This is your sum of squares for your regression or the error. All right. All right, so let's get into this. I'm going to grab this. Here's the formula. Copy that, paste that, SSR, gimme, gimme, SST, double click, click it. All right, and that will be your R squared value. And don't forget, if your R squared is above zero point 0.7, it is a good correlation. This is a very good, excellent correlation, 0.97 or 97.5%. Pretty good. All right. Your R squared adjusted is where you're taking all of your independent variables and checking to see, did it really affect the final results? All right. How well is this correlated based on all of these independent variables? Here are your formula right here. Grab it, paste it. All right. R squared is what we just calculated. N, all right, is what was given. N is what was given, and your p-value is how many x values do you have? All right, so when you press that, your r squared adjusted is going to be slightly less than your r squared value. All right, so as you can see, this one is still 97%, but 97.5.1%. All right, and once again, it provides an excellent fit. Outstanding. So you can just say, all right, it provides an excellent fit. All right, good work. Let's go to 15.35, please. I'm going to bigify this just a tad bit so you guys can see this a little better. All right, 15 dot, did I miss one? Yes. Let's go to 15.20, please. 15.20. Perfect. All right. So we got two X's and the end result of y's or wives. All right, so you can copy this. Hopefully it pastes in there correctly. Yes, indeed. Yes, indeed. All right, we're going to do a regression analysis. I'm going to maximize this so you guys can see this holistically. Data, data analysis, regression, press OK. All right, please get rid of all of these. Get rid of all of these. All right, and this, get rid of it. All right, put your y's with your y's. All right. And the cool part about multiple regression is that you can put both of them into your X's. Include both the labels and go all the way down. And we're going to drop this output right at H1. Yeah. We're going to press OK. What we're going to see, here is your B0. Here is your B1. Here is your B2. All right. Right here is your p-value, your overall p-value. Let me put overall p-value. All right. How does these independent variables affect the end result? All right. And here is your test statistic. All right. I'm going to just drag this over so I can see the word test statistic. All right. Don't forget, this number right here, it means e to the negative 0.5. Move your decimal place 5 places to the left. All right. So if you don't want to see it like this, you can click on your home tab, and instead of a general, you can change it to a number. All right. And remember, with p-values, you want 4 decimal places. So you can move it over 4 decimal places, but I'm going to move it over to the 5th decimal place so you can see the first number show up. Yeah. This is why it says e to the negative 0.5. Move your decimal places 5 places to the left. So I'm just going to move it over to 4 decimal places as normal. So what this would mean is that, yes, your X's do affect your Y's. And then to figure out which X actually affects your Y to make it change, you can look at the p-value for both of them. All right. Is this number less than 0.05? Yes. So this one does affect your Y. Is this number less than 0.05? Yes. So this one does affect your Y's. Yeah. And you can make a comparison which one affects more, but you can't really say that. Anyways, you can see your results right here. All right. So I believe that this one, let me look, is an exam question as well. Let's scroll through and see. We're going to be looking at for the exam. Once again, these show up in your PowerPoint. 15.20 will be on your exam. All right. That's a little slightly off. All right. And then 15.075 will be on your exam. All right. Good, good, good. So let's make sure that we get this one correct. So you guys saw how to do the output. All right. Right here, your F value. All we do is put equals to and click the number. Yeah, yeah. All right. So for your p-value, for your overall p-value, we're going to put equals to and click it. But we're also going to, oh, let me click it. All right. But we're also going to put in the actual words that go along with it. All right. So let's go to this next one right here. How do we find TB1? Put equals to, all right, your TB1. All right, so you guys can actually see this. I'm going to click on this guy right here. This is my T. Here's my B0. Here's my B1. Here's my T B1, if that makes sense to you. All right. My P value for my B1 is this guy right here. I'm going to press enter. All right. And I'm going to go down here, my TB2. And then my p-value is going to be this guy for my TB2. All right. So I'm going to slide this over. I'm going to grab my Cengage as well. All right. And you guys are going to be able to plug in your F value. All right. This is going to be less than 0.01. So to the right, please put in less than 0.01. All right. And the result is going to be significant. Let's just check just to make sure. Outstanding. So you're going to put right here, SIG, or you can put the whole word significant. All right. Good. So for the next one, we're going to put in our TB1. This is going to be less than 0.01, and it is significant. So let's check, make sure that we're right. Yes, indeed. All right. So we're going to put to the right here is, and then actually, sorry, this is less than 0.01. And in here, we're going to put is. All right. Same concept down here. We're going to put in our TB2. This is going to be less than 0.01, and it is significant. Outstanding. So please make sure that you have everything set up correctly. So when you get to the exam, there is no guesswork. Yeah, yeah. All right, good work. Two more to go. Let's go, let's go. Can we go to 15.35, please? Scroll up. All right. What we've done is we've already downloaded this information for you guys in our Excel right here. So here's the raw data. You can actually take raw data, categorical data, and convert them into actual numbers. So that way you can actually use the regression equation. So for example, initially we had electricians, the type of repair, electrical repair or mechanical repair. We can say, let's say electrical is 0. And let's say mechanical is 1. So this is what we did, type of repair. For every electrical, we put it as 1. For every mechanical, we put it at 0. So we went through and did this whole part right here, just for repair time and just for type of repair. Then we did the same thing for the end result, the repair time, and we did it for different persons. So if you had different persons' names, you can change them to ones and zeros or different numbers and calculate and use the regression analysis to determine, is there a correlation or not? And then you can make predictions and so on and so forth. So once again, for Dave, we made him 1. For Bob, we made him 0. So every time Bob shows up, we hit 0. Every time Dave shows up, we hit 1. All right. So what we're going to do is two regression analysis. All right. One for type of repair and one for repair person. All right. So now that you got that concept, I'm going to maximize this. All right. And I'm going to go data analysis, regression. Yep. Press OK. All right. Once again, just clear these out. Clear all of this out. All right. Once again, we put our X with our X's and our Y's with our Y's. All right. So right here, we provide you a hint. The time is your Y, and the X's are your type of repair. All right. So for my Y's, please make sure that you put time. These are the end results. All right. Whether it's the electrical or mechanical situation, the end result is the repair time. All right, good. For your X's, so you guys can see this a little better, this is the type of repair. All right, and we're going to put this output right here. All right, so just press OK. Bam. Here is your B0. Here, which shows up right here. Here is your B1, which shows up right here. All right. I would set this probably to 2 decimal places. I'm going to move it over to 2 decimal places. Yes, indeed. All right. And is it a good fit or not? I can look at my R squared value. Yeah. All right. Point uh, 0.08. Nah, it's not a good fit. All right. But I'm going to slide this over. Let me bigify this. All right. And let's type in our two numbers. All right. And I'm going to check my work. Outstanding. All right. Your job is to answer these questions right here. All right. Yes or no. Once again, they're drop downs. Just get them right. Just get them right. All right. But right here, because the p-value of something shows a relationship, all right, what is my p-value? And I'm assuming that they're talking about the overall p-value. So I'm going to yellowify this and I'm going to make it 4 decimal places. All right, so let's see. And once again, we should all have the same numbers. So yes, so please make sure that you have your overall p-value right here. I'm going to double click on it to move it over. Don't forget, this is your overall p-value. All right, once again, this is your test statistic. All right, so now that we have that, let's go to this final one right here. Let me maximize this. We're going to go data analysis. We're going to go regression, press OK. All right, I'm going to clear all of this stuff out so there's no confusion. All right, and I'm going to block this one out and just use repair person. All right, so I'm going to click on my Y's. Don't forget, the Y is the end result. So on this Y, I'm going to select repair time. Start from repair time, go all the way down. For my X's, I'm going to start from repair person, go all the way down. And for my output, I'm going to drop this right here. All right. So please drop it at B40. All right. Once you have all of that stuff, press OK. Spacker. All right. For your B0, put equals to, click it. This is your B0. All right. For your B1, put equals to, click it. All right. I'm going to slide this back over. All right. So here's my B0. And here's my B1. If it's a negative number, please put in the negative number. Once again, we all have the same numbers. Outstanding. All right, so for these drop-down boxes, just get it right. Just get it right. You got this. All right, so read into the problem, read why which answer is correct. All right, good work, good work. Let's go to the last one. Multiple choice 15.075. All right, I'm going to go to this last one right here. All right. So on this one, all right, in a multiple regression analysis, it involves 10 independent variables and 81 observations. Your SS1 or your SST is 120. All right, so you would manually type in 120. All right, your SSE is 42. All right, and you can find out what your R squared value is, your coefficient of determination is. And in this example, it is this answer right here. All right. All we're asking you to do is ratify your answer, and you'll be good to go. All right. So once you're done with all of that stuff, submit for grading, please. So, as you can see, our final class, our final chapters, 14 and 15, dealt with regression analysis. We can actually see the correlation. All right. Is it a strong correlation? Strong positive, strong negative. If it's going upwards, it's positive. If it's going downwards, it's negative. All right. And based on the trend line, is it a good correlation or not? Anything above zero point 0.7 is considered pretty good. All right. And then we can make some forecasts and we can make some prediction by using the simple line formula. Ultimately, we should be able to see that we can look at stuff that is independent and see how it affects or change the dependent variable and make informed decisions from that. So as you go into real life, man, make good choices and understand that your choices affects your legacy. Man, go out there and have a great legacy. Let's go, let's go. Thanks for hanging. Have a blessed day.